this video, we are continuing with analytical geometry and we will be working with triangles. So we are going to answer a few questions based on this triangle. We'll prove whether or not it's a right angle triangle, find its area, find the equation of a few lines, and also find the sizes of different angles within this triangle. So the first question is, prove that triangle ABC is a right-angled triangle. So by looking at the diagram, we can find the gradient of line AB and the gradient of line BC, and this angle B is most likely to be the right angle. So let's start by finding the gradient of AB. So the gradient of line AB is the difference of y's over the difference of x's. Then I substitute the y coordinates in and the x coordinates in. Simplify the numerator and denominator and find the gradient is -3. Similarly, I can find the gradient of BC. And if I need to prove that the triangle is a right-angled triangle, I need to find one angle equal to 90 degrees. So therefore, the gradient of AB multiplied with the gradient of BC is equals to -3 times a third, and that is equal to -1. Therefore, we can say that the line AB is perpendicular to the line BC. Therefore, triangle ABC is a right-angled triangle. Our next question is to calculate the area of triangle ABC. So we already know that this is a right-angled triangle, and therefore we can say the area is the base times the height. So we'd need to find the length of the base, BC, and the height, AB. So I use the distance formula to find the length of BC. So using the distance formula, substituting the correct values in and simplifying, I find that the length of BC is 3 square root 10. And now I would use the distance formula again to find the length of the line AB. So I see that the length of the line AB is 2 square root 10. And because it's a right-angled triangle, I can say the area of triangle ABC is equals to the half of the base, BC, times the half of the height, AB. So that is a half times 3 square root 10 times 2 square root 10. So therefore, the area of triangle ABC is 30 square units. Our third question is to find the coordinates of K, the midpoint of BC. So K is the midpoint between B and C. So it is the x values added together divided by 2 and the y values of B and C added together divided by 2. So therefore, the coordinates of K is a half and minus a half. Notice the notation, we don't say K is equal to, we say equals K. And K is right next to its coordinates. So there's no equal sign between the letter and the coordinates. This is the correct notation. The next question is, find the equation of the line through K and parallel to AB. So notice now that this answer is determined by our previous answer. So it's important to work accurately and methodically through these questions as we go. So in order to find the equation of a line, I need to find the gradient and the y-intercept, or I could use the formula which we find on the grade 12 formula sheet in our final exam. And we need to find the gradient and use one point on that line, and that point would be K. So because the lines are parallel, the gradient of the line which we are trying to find would be equal to the gradient of line AB. And in a previous question, we have already found that the gradient of AB is equal to -3. Now, if we use the equation that we find on the formula sheet, we already have the gradient as equal to -3, and then we need x1 and y1. The x-coordinate of k would be x1, and the y-coordinate would be y1. So I substitute the y and the x coordinates of k into this equation. Then I multiply out and simplify. And therefore, the equation parallel to AB through k is equal to -3x plus 1. Our next question is, determine if the midpoint of the line AC lies on the line found in question 4. So in the previous question, we found the equation is equals to y minus 3x plus 1. And we want to know whether the midpoint of the line AC lies on this line. So first off, we need to find the midpoint between the line AC. So we find that the midpoint of AC is -1/2, and the y-coordinate is 2.5. And now to determine whether or not this midpoint lies on the line that we found in the previous question, we need to simply substitute the x value in. So if I substitute the x value in, and if I simplify this expression, then it will be equal to 5/2 or 2.5 if it lies on this line. So this becomes 1.5 plus 1, which is 5/2. After I have substituted the x-coordinate of the midpoint into the equation, I found that the y value is 2.5, which is the same as the midpoint. Therefore, we can conclude that the midpoint of AC lies on the line y is equals to -3x plus 1. And in our final question, we want to find the size of angle BAC. So we want to find the size of this angle. Here I can see that I already have a 90 degrees within this angle, and that I only need to find this angle size. That will take some calculation. Alternatively, we can extend this line, and let's call this line theta, and let me call this angle beta. Then I can see I can use exterior angle of a triangle is equals to the opposite interior angles, like we had in our previous video. And I can use the angle of inclination between the line AB to find beta, and I can use the angle of inclination between the line AC extended straight to find the angle theta, and then this will be exterior angle is equals to the opposite interior angles, and in that way find angle A. So let's do the maths. We already have the gradient of line AB is equals to -3. And because it's negative, we use a reference angle. So in one of our previous videos, we mentioned that the reference angle is the angle before the axis of symmetry and the line when it's obtuse. So therefore, beta would be 180 degrees minus the reference angle. So beta is 108.43 degrees. Now, when we make changes to a diagram like we are doing now, it's important to either redraw the diagram, or if you're writing a paper 2 final, to show the changes which you are making on the diagram. So you would fill in beta and you would fill in theta and extend that line, and you would hand that in as part of your answer sheet. Now for theta, we have the gradient of line AC. So the gradient of line AC is -3/11. And because it's a negative angle, we're going to use a reference angle. And when we substitute into our calculator, we take the reciprocal function of tan and we only substitute a positive value in. So 15.26 represents this little angle on the inside. And now you see I have two angles already on the interior of a triangle, and I can solve A by saying sum of angles in a triangle. But if I follow my original plan, then I will have theta is equals to 180 degrees minus my reference angle, which is 164.74 degrees. And then I can say theta is equals to beta plus angle BAC, exterior angle of a triangle. Then I simply substitute the values of theta and beta into this equation in order to solve angle BAC. Therefore, angle BAC is 56.31 degrees.